Hello everyone. In this meeting, we will discuss data types, variables, and arithmetic operations in Rust. In this section, we will talk about comments in Rust. Create a new file named comment.rs. Then I will create the main function, which is where the program starts. A program comment is a part that is not executed by the program. Comments are used to clarify program information, documentation by the author, and so on. Here is an example of a single-line comment. A single-line comment starts with double slashes. The code inside the comment will not be executed by the program. I will try to compile and run the program. No output is displayed because the code is inside the comment, so it is not executed by the program. Now let's try removing the comment in the code, then compile and run it. The output number 5 appears in the terminal. Now let's try to print the number 6 without removing the print statement for number 5 using a comment. Let's try displaying both by removing the comments so that both 5 and 6 appear in the terminal. In addition to single-line comments, there are multi-line comments that start with a slash asterisk and end with an asterisk slash. Multi-line comments are usually useful when you don't want to execute a large part of the code or just for code documentation. Now let's try adding code in the multi-line comment. Then we will comment out the code above. Next, let's compile and run the program. As we expected, there is no output in the terminal. Now let's uncomment the code and run the program. Yes, the numbers appear. Multi-line comments in Rust are different from multi-line comments in C or C++. In Rust, multi-line comments can be inside other multi-line comments. The structure is the same as the multi-line comment using the slash asterisk, ending with an asterisk slash, but it is inside another multi-line comment. Okay, that's all for the discussion about comments in Rust. Next, I will commit and save it to the repository on GitHub. Okay, now let's move on to the next section about data types in Rust. These are the primitive data types in Rust, ranging from integers, floating point numbers, Boolean, and Char. You can see the name of the data type, its size in bytes, and the range of values for each data type. I will create a file named datatype.rs for this section. First, let's look at an example of using integer data types in Rust. Here I will give an example of creating an integer variable. We use the keyword let to create a constant variable, followed by the variable name, then a colon with its data type, and then assign a value to the variable. You can try experimenting by giving different values than I used. Integers cannot store values that have a decimal point. Some integers can store negative values, and their data type starts with the letter I. For integers that cannot store negative values, their data type starts with the letter U. Next, there is the float data type, which can hold numbers with decimals. This data type is suitable for division operations. Then there's the char data type to store characters. Unlike char in C and C++, in Rust, the char data type is Unicode, so you can even store emojis in it. This explains why char in Rust is 4 bytes in size. Next is the Boolean data type, which stores the logical values true or false. That's all for the primitive data types in Rust, from integer types, floating point numbers, characters, and Boolean values. Next, I will print all the variables to the terminal. In this print function, there is a string with curly braces inside it. Those curly braces will be filled with the values of the variables passed to the print function. Let's compile and run the program to see the output in the terminal. You can see in your terminal the output, each variable printed with the values as defined in the code. For example, here is the first line of output. It comes from line 25 in the code. The string printed to the terminal matches the code, but the curly braces are filled with the variable's value. This applies to all other variables as well. For input and output, that will be covered in the next video. Now, I will commit and save it to the repository on GitHub. That's all for the discussion on primitive data types in Rust. Okay, now we will discuss the various types of variables in Rust. Data in Rust can be in the form of variables or constants. When using variables, there are naming rules that must be followed. The first rule is case sensitivity, meaning that if a variable has the same name but with different cases, it will be treated as different variables in Rust. The second rule is that variable names can only contain alphabetic letters, both uppercase and lowercase, numbers from 0 to 9, and underscores. The variable name must start with an alphabetic letter or an underscore. The final rule is that a variable name cannot use a keyword already reserved by the Rust language. Here I will show you which keywords are reserved by the Rust language, so we cannot use them as variable names. Okay, next let's discuss the types of variables in Rust. The first type we will discuss is constants. Constants are created using the keyword const. Constants are values that cannot be changed, immutable, must be defined with a specific data type, and can be used anywhere in the code. Constant values are evaluated at compile time. Constants must have their data type annotated, cannot be mutable, are globally available throughout the crate, and their names follow the convention of using uppercase letters. Next, there are local variables. Local variables are the most common type and are defined within a function or block. By default, variables in Rust are immutable, meaning their values cannot change unless explicitly declared as mutable using the keyword mut. For example, the variable y can change its value because it is given the mut keyword, while the variable x cannot. Additionally, local variables only exist within the scope or block in which they are defined, meaning they are not known outside the function or block. Local variables are automatically deleted when they go out of scope. Next, there are static variables created with the static keyword. Static variables are global but have a fixed memory location and exist for the entire program execution. These variables can be mutable by adding the mut keyword, but accessing mutable static variables requires an unsafe block because it risks causing a data race. Mutable static variables are not safe to access directly, and using an unsafe block is necessary to read or write them. Here we can see how to use static variables. Mutable statics are used in an unsafe block, while regular statics do not need one. That's all for the explanation of the types of variables in Rust, including constants, mutable and immutable local variables, and mutable and immutable static variables. Now let's try compiling and running the program. Yes, the output is as expected. However, we should pay attention to the warning messages during compilation. The first and second warnings are simple because we created a constant but did not use it in the program. The third warning occurs because we used a mutable static variable. In the code above, you can see the constant that was created but not used in the program. Okay, that's all. Now I will commit and save the code to the GitHub repository. Now we move to the final part of this chapter, which is about arithmetic operations. Here you can see the first operator, which is the assignment operator used to assign values to a variable. Then there are arithmetic operators used for basic mathematical operations such as addition, subtraction, and so on. Finally, there is the compound operator that compound arithmetic operations and then stores the result in a variable. Okay, let's create a new file for the code. Here I will create a variable x that can change its value because it will be used for the combined operator, and a variable y that cannot change its value. I will make an example for all the available operations. Let's compile and run the program. You can see the results of the arithmetic operations. Keep in mind that because we are using integer values, when division is performed, the result does not have a decimal point. If you want a decimal point, you need to give the variable a floating point data type. Also, note that for operations using the compound operator, the value of the variable x changes. Okay, next I will commit and save the code to the GitHub repository. That's all for this chapter. We have covered comments, data types, types of variables, and arithmetic operations. Don't forget to like, subscribe, and share this video. See you next time.